Welcome back to the Megacell Monitor video channel. And it's been some time that I recorded the video, but that's because we were so crazily busy with the new energy cells charger boards that at some point you need to choose, do you make a video or do you continue the development? And of course we received from Alex Gradea the Fomimo printers, which are a very small form factor label printer, which is now also compatible with the Megacell Monitor software, allowing you to print different types of labels for a extremely affordable price. Now, most unfortunately, China is closed, but once Alex has a new stock, then he will let you guys know. If you ever want to choose between a label printer or buy something that is off the bat a lot cheaper than the Diamotor Brothers, then the Fomimo is a very good alternative. Aside that, the energy cells charger board. Now, we've already touched upon that several times. It's working, charging, discharging. We all got it to work. There are a few things that we were not aware of when we actually developed this one on paper. One of them is the chip that we're using for the discharge has quite a lot of intelligent features, including a short circuit detection system. And when we can basically added all the resistors on the back to be able to discharge with 5 amps, it was identified that the chip actually thought it was a short circuit because of the extremely low resistance across those resistors. And it triggered basically a short circuit. So what we had to do is basically remove half of these resistors to get it working. Also, during the prototype manufacturing, we have spare parts due to the chip shortage, like 2 different oscillators for the clock signal for the board. And by accident, the manufacturer thought that both clock signals were needed, whereas they were in the drawings as optional. So they soldered, and on the front and on the back, a oscillator basically ending up on the same chip. So we didn't have a 60 megahertz frequency, but it ended up somewhere random between 16 and 32. So that, threw us off for quite some time, where we didn't get the SPI to work. Now, so how far did we get today? Well, as said, charge and discharge is working. And over the Easter weekend, I'm going to combine 2 of those boards, making a 16S prototype to see if all is working as per design. And in the background, in the past couple of weeks, we have been working on enhancing the board with additional features. Now you can see here that we still have 16 holes for the connectors. We promised to build a 4-wire measuring system, and this one is still a 2-wire. So basically the same 2 wires are used for charge and discharge. And the next revision, this is going to be dropped, and we're going to have 4 connectors. 2 are being for the charge and discharge currents, and 2 are for the voltage measurement, to get it as close as possible to the terminals of the battery. And then it doesn't matter if you're using the standard 18650s or you're using the battery packs with screw terminals. In principle, all are supported. But let me take you through the development process, because I took a few videos that shows where we were a couple of weeks ago and where we are today. So let me show you what we've done. So this is my development environment. I got a nice dual screen, and from my machine you see a wire running to the, previously the meeting table, where we have the energy cells charger connected to a breadboard. You see that we are using a new screen with a higher resolution, 240 by 240, which makes it very easy to read, and you can put a lot of information on the page. And at this point in time, we're basically debugging the SPI interface to see if everything is working as it should be. Now, everything is connected to a lab monitor, lab power supply, to provide the necessary power to the board. And here we are testing the PWM signal of the energy cells charger. So from the testing bench we went to building a rig. It has a 3.3 volt, 5 volt and 20 volt power supply, and the energy cells charger is mounted to the board and the breadboard together, allowing it to run continuously and see if the workflows are working as expected and the application does what it's supposed to be doing. After a lot of testing and prototyping and revalidating, changing the firmware and software, we finally got the workflow running as it's supposed to. Of course, we did first a charge, then we did a discharge, and eventually we run the workflow. And this one was the first one that actually started and completed from beginning till end, which was a great success. If you made it this far into the video, then you really enjoy watching the Megacell monitor and energy cells charger development. And let me take this opportunity to thank all our patrons that make this video channel go forward. All the equipment that you saw I bought with my own money to make sure that we are developing a stable, reliable product, and also be able to see what's going on. And without the patrons, that's not possible. So if you're not a patron yet, please subscribe, please become a patron and help to keep this video channel alive, and of course the development of the Megacell monitor and energy cells charger. And feel free to provide also suggestions and questions. There are a lot of updates in the upcoming release, but that's a video on its own. So thank you very much, and yeah, keep charging.